The first chapter, overview of the first chapter. So first chapter, what is that? Reflection of light. Reflection of light at curved surfaces. Reflection of light at curved surfaces. This is a chapter 1. Reflection of light at curved surface. Okay. So what are the main overview of the chapter? Overview of the chapter. So first in this chapter we discuss about the first concept, what is reflection. Reflection. Second one, Fermat principle. Fermat principle. And third one, Fermat principle. And third one, mirrors. So mirrors are mainly two types. Mirrors are mainly two types. That is, one is plane mirrors, and one is spherical mirrors. Plane mirrors, spherical mirrors. Again, spherical mirror divided into two types. What is one is a concave mirror and one is a convex mirror. Convex mirror, concave mirror. And fourth, we'll discuss about detail later. So next, ray diagrams. Ray diagrams of both mirrors. Ray diagrams of both mirrors. Ray diagrams of both mirrors. So I'll explain once again. So what is the chapter? Reflection of light at curved surfaces. So overview of the chapter. Reflection, Fermat principle. Mirrors are two types, mainly plane mirrors, spherical mirrors. Again, spherical mirrors are two types of concave mirror, convex mirror, and ray diagrams of both mirrors. Okay. Off. So next, ray diagrams is very important. Before going to ray diagram, first we need to understand what is a concave mirror, what is a convex mirror. So concave, it's a concave, it's a cave. So like this, I'll draw the diagram here. This is a concave mirror. So I'll explain about the convex mirror. So this is the convex mirror. Convex mirror. Or else we can take the convex mirror like this. Convex. So mainly concave, convex. Concave mirror is called as converging mirror. It is called as converging mirror. And convex mirror is called as diverging mirror. Converging mirror, diverging mirror. Concave mirror, convex mirror. Concave mirror is called as converging mirror, convex is called diverging mirror. So concave mirror always, the concave mirror focal length should be, it's a negative. So focal length should be negative concave mirror. And convex mirror focal length should be positive. It's a positive. Focal length mirror is a positive. So concave mirror focal length is negative, focal length convex mirror is focal length positive. And concave mirror will get the image real and virtual. Just will get. In a concave mirror, real image and virtual image, both images can get. But in a case of convex mirror, only virtual image. Only virtual image. In a case of convex mirror, is a virtual image. So I will explain what is the real and what is the virtual. When we talk about real image, so real image is nothing but it is a converging. Whenever the light rays passing through a object, they meet at a certain point. That is called converging mirror. Then we can say that the definitely real image. Real image can be formed. So real image is nothing but it is inverted. So real image is nothing but inverted. Whenever the inverted image is nothing but real image. Whenever the image should be inverted, definitely that is a real image. So when this is formed, when the converging light rays, that's why we call as converging mirror. Converging parallel light rays. What do we call? Converging parallel light rays. Converging parallel light rays. Next, virtual. It is also called as upright. Upright. Upright or erect. Upright or erect. So virtual image mainly formed when the parallel rays diverging. Whenever it's a diverging rays, that doesn't meet at a certain point, then we get the virtual image. So virtual image, and moreover, virtual image is definitely it is a erect and upright. Only in the case of convex mirror, only one case will get the virtual image, convex mirror. But in the concave mirror, we'll get both the real and virtual image. Both will get real and virtual image. Virtual image. Real and virtual image. These are all we are discussing. Differences. So real image can be captured on the screen. It can be captured on the screen, and the virtual image does not capture on the screen. It can be captured on the screen and does not capture on the screen. So when it is real image form, when the light rays, parallel rays converging at a point, that is, in that case we can form as a real image. The real image should be inverted. The real image should be inverted, and definitely concave mirrors can be performed real image and both virtual image. But convex mirror only we can get the virtual image. That is a virtual nothing but it is a erect or upright, we can call it as upright. Next we are moving to magnification. Next concept is magnification. It is denoted with small m. Magnification nothing but small m. So what is the magnification? Height of the image per height of the object. So we can say that hi by h naught is equal to hi here. What is that? Hi is equal to hi by h naught is equal to minus v by u. This is the expression of magnification for mirrors. Hi by h naught is equal to minus v by u. Hi by h naught is equal to minus v by u. So what is hi? I will explain here. Hi stands for height of the image. Height of the image. And h naught stands for height of the object. Height of the object. Height of the image, height of the object. So here, height of the image, H0 stand for height of the object. Here one more. V stand for image distance. Image distance. And U stand for object distance. I'll explain again. Magnification nothing but height of the image by height of the object is equal to minus V by U. This is an expression, mathematical expression. V stand for image distance, U stand for object distance. U stand for object distance. If magnification, these are the very important condition. Three conditions is very important. Magnification. If magnification M is equal to 1, if magnification is equal to 1, that indicate it is a plane mirror. Okay. If magnification is less than 1, it is called as diminished. It's a diminished image. If magnification is greater than 1, it is called as enlarged, highly magnified. Let's take a concave mirror. It's a concave mirror. It's a cave, already said now. Concave means inwards. It's a concave. So this is called pole. It's called as pole. And this is called focus. And this is called center of curvature. And nothing but angle of incidence must be equal to the angle of reflection. Angle of incidence must be equal to the angle of reflection. I1 is equal to IR. That we discussed earlier in the class. So here P stands for pole and F stands for focus and C stands for center of curvature. What do we call? Center of curvature. So here definitely the distance between the pole and focus is called focal length. This is called denoted with small f. The distance between the distance from P to F. P is nothing but pole, F nothing but focus. So distance between the P and F is called as focal length. And from the P, it means pole to center of curvature, this total distance is called radius of curvature. What do we call? Radius of curvature. R stands for what? Radius of curvature. R stands for radius of curvature. That is the expression finally we can get. R is equal to 2F. The radius of curvature is nothing but double of the focal length. So can we get, from this expression can I write R by 2 is equal to F. Nothing but half of its radius. What is the focal length? Half of its radius of curvature, nothing but focal length. R is equal to F, then R by 2 is equal to F. So it's a double of the focal length. So, and finally, in this chapter we can do the problems also by using the problem mirror formula. It's very important. Mirror formula is very important. That I'll write here. Mirror formula: 1 by F is equal to 1 by V minus 1 by F is equal to 1 by V plus 1 by U. It's called as mirror formula. 1 by F is equal to 1 by V plus 1 by U. 1 by V plus 1 by U. Where, I'll write here, where F stands for focal length. And V stands for image distance. And U stands for object distance. ఒక్క నిమిషం చూద్దాం. Chemical equation, chemical reactions. Chemical equations, chemical reactions. What is the importance of chemistry? What is the importance of chemistry? So chemistry nothing but it can save the life, it can fatal the life. Both is possible. It can save the life, it is a fatal the life. So that is a very very important chemistry. It comes under, it's a chapter related to chemistry, not physics, it's a chemistry. So chemical equation, chemical reaction. So for example, why we go for the chemical reaction? Why we go for the chemical reactions? So simple answer, to get new compounds. 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 According to law of conservation of mass, according to law of conservation of mass, according to law of conservation of mass. What is the law of conservation of mass? The reactants. If you write a reaction, for example, I will write. So, if any reaction, let us take any reaction. What is it? For example, zinc is there. Zinc react with the hydrochloric acid. It's formed as a ZnCl2 plus hydrogen gas. Okay. So let's see. So here this is it. Observe this arrow mark. Arrow mark in chemistry field there is a lot of importance. The special character is there. The arrow mark right side is all called as products. It's called as products. And the left side is called as reactants. Reactants. So law of conservation is nothing but the whole mass of the reactants will be equal to the whole mass of the product. That is called law of conservation of mass. So here the left side is called as reactants and right side is called product. The left side is called as reactants and right side is called as product. So here the left side is called reactants and right side is called as products. So above indicate it is a presence, and down is indicate catalyst. So what is the catalyst? So catalyst nothing but it does not involve the reaction, but it can access, it can change the state of the reaction, whether increasing or decreasing. That is called catalyst. So here, and one more. So here indicate I am writing H mu. It is called as sunlight. Some reaction. For example, let us see the photosynthesis reaction. Photosynthesis reaction nothing but to get the food, whatever the plants themselves, that does not depends upon others. It's called as herbivores. They can produce their food by themselves, self-produce. So it required sunlight. So H mu is nothing but sunlight. And here delta, it is called delta. Delta is a Greek word. What is delta? Delta nothing but change. For example, if I write delta M, change in mass. If I write delta capital T, change in temperature. So these are the examples. So here delta means change. So now in the chapter mostly emphasized, you have to focus most is balance equation. What is that? Balance equation. is that balancing? Cl will form as a Zn chloride plus hydrogen gas liberated. So here, this is not a balance equation. So it's called as balance equation, nothing we call as skeleton equation. What do we call? Skeleton equation. So the following equation we need to balance. We need to balance. So we'll go for the box method. This is a very, very important. By this method only we can do any kind of balance equation. So first column we have to write the elements, and second column we have to write the reactants, and third column we have to write the product. Okay. So what are the elements present given by the following equation we have to write here in this box? Zinc, hydrogen, it's a chlorine. Is there any? Okay. Zinc, hydrogen, chlorine. And what are the reactants? Okay. How many here? Zinc. Here one is there. Hydrogen here how many? 1. Here chlorine. How many? 1. Here products. Zinc how many? 1. And chlorine. Hydrogen here how many? 2. And chlorine we have how many here? 2. So this is the balanced. So zinc is balanced. Here 1 is there. You have to see the coefficient 1 or 1. No need to balance. It's already balanced. So remaining hydrogen here reactants is 1 is there, but products 2 is there. We need to balance here. So simple here 2 is there. Just we multiply with 2, we get the 2. Third, chlorine. Here how many is there? 2 is there. Products. Reactant 1 is there, but in product 2 is there. So here also we have to make a balance. So we get multiply 2. Now the balanced equation we are writing zinc plus how many? 2 HCl gives rise zinc chloride plus hydrogen. It is a balanced equation. So basic steps we have to follow. First we have to write the elements. Then we have to check the reactants. How many reactants are there? Next we have to check the products. How many products are there? With what number we can multiply, we get the final balance equation. That we have to think. Okay, understand? So next we will move on next level. Interpret balance equations. Interpret a balance equation. So here basic steps is there. What is the physical state? Physical state. Second one, gas evolved. Third one, heat liberated. So we'll go for one by one. Physical state. Physical nothing but what are the physical state you have? One is a solid, liquid, and gas. Whenever the gas evolved, arrow mark will show upwards. And fourth one here, one more is the precipitate. Precipitate formula. I'll explain, don't worry. So these are the main. First one physical state, second one gas evolved, third one heat liberated, fourth one precipitate form. So first one physical state. Whatever the given the balance equation, what are the products, what are the reactants, they have the generalized form, whether they may be solid or liquid or gas. That we call as physical states. Gas evolved. While doing the any reaction, any chemical reaction, is there any gas evolved? That will show arrow mark upwards. For example, in the case of zinc react with hydrochloric acid, it will form as Zn chloride. Hydrogen gas will be liberated. Hydrogen gas will be released. And heat liberated here. Heat liberated here, third one, heat liberated, we have the two types. One is the, what is that? exothermic reaction and endothermic reaction. Two types are there. Exothermic, endothermic. I'll explain one by one. Exothermic. What is exothermic? Whenever they are doing the reaction, heat is liberated. Means heat released. Heat released. It's called as exothermic. Heat. We're talking about here gas, heat. We're talking about here gas release aroma same, but here heat. Heat released. Exo. And endothermic. Called as heat will liberated with denoted with the Q. It's related with heat. Heat. Q. And endothermic, whenever the heat absorbed. Whenever the heat absorbed, that is called as endothermic. Whenever the heat released, it's plus Q. And endothermic is minus Q. You can take them minus or plus. Endothermic, exothermic. So definition is very, very important. Exothermic, whenever the heat is released, whenever the combustion reaction, heat will be compulsory produced. Heat will be released. Sorry, produced, not released. That is called exothermic. And endothermic, heat absorbed. Heat is absorbed in the reaction that we call as endothermic reaction. Next one. Precipitate. Precipitate will show the downward arrow mark. Precipitate nothing but any substance which does not dissolve in the water, which is undissolved, will form as a layer like a precipitate, white layer in the beaker or in the test tube. That is called as precipitate. That is called as precipitate. That is called as precipitate. Okay, which is convert in any chemical equation. How many moles that we'll discuss here. So first one, the relation mass relation. Mass relation. Second one, mass volume. Mass volume. And third one, volume. Volume. And fourth one, mass volume, comma, number of molecules. Number of molecules. So here volume I'll explain. First one, mass relationship. Mass relationship. Second one, the value 6.023. 6.023 into 10 to the power of 23 molecules. 23 molecules. 6.023 into 10 to the power of 23 molecules. It's a Avogadro number. It is called as Avogadro. The name of the scientist Avogadro. Okay. Understand? Mass relationship, mass volume relationship, volume, mass volume, number of molecules. So in this kind of, if you know this one, we can do the problems. Okay.